Good morning, students. Okay, so basic concepts related to organic chemistry. Okay, so that's what we were discussing, right? So in the last class we have discussed about anyone can you tell me what we had discussed in the last class? Yes, good morning everyone. Anyone can you tell me what we had discussed in the last class? Okay, yes, Gauri. We were talking about isomerism. Very good. So we were talking about isomerism, right? Different way of isomerism. Yes, both of you correct. First, we have discussed about chain isomerism, right? Then we have discussed about functional group isomerism. Functional group isomerism or functional isomerism. Then we have discussed about, any one of you have written? Okay, type of structural isomerism, yes. But in structural isomerism, only these two. Okay, then we have discussed about position isomerism. Very good. Then we have discussed about final one is, which is that final one? Yes, this metamerism. Very good. Metamerism. So that's what we have discussed in the last class. And as you people have told, they belongs to structural isomerism. They belongs to structural isomerism. Okay. Now that's where we have the chain isomerism, where there will be difference in the parental chain, but molecular formula will remain same. Now when it comes to functional group isomerism, where molecular formula will remain same, but there will be different functional groups. When it comes to position isomerism, this is with respect to position of functional group or double bond in a molecule, which will be having same molecular formula. Now metamerism is related to, once again, same molecular formula but different alkyl groups on the either side of the functional group. Majorly applicable for ethers. Majorly applicable for the ethers. Okay, see for example, so don't get confused. See for example, I have CH3, CO, CH3. So this is one molecule. Oh, okay, this one I cannot tell. I have to take pentane. CH2, CH3. Because it's butane and propane, I cannot talk about acetone. Now this is a molecule with anyone? This is pentan 2O. Right? This is nothing but pentan 2O. Now same way I can write another molecule that is pentan 3O or pent 2O or pent 3O. Both are isomers. Now both are isomers, whether they are metamers or whether they are any other isomers. Anyone can you tell me? So whether they are metamers or whether they are any other isomers. Can you tell me? This can be an example for what? Whatever I have written on the board, this can be example for. Can any one of you tell me? This can be an example for. Hmm? So this is an example for positional isomers. They are the example for positional isomers. That is because in both the cases, parental chain is remaining same. Parental chain is remaining same. But when it comes to metamers, parental chain will vary among the isomers. Please remember, that is the difference between position isomers and metamers. Many students, they will get confused between these two. Got my point? So when it comes to position isomers, so which talks about position of a functional group or position of a double bond, but parental chain will remain same. So in both the cases, it is pentane derivatives. Okay? But when it comes to metamers, that's where they differs with respect to each other, even in that parental chain. So if you remember yesterday's class, ethoxyethane, but another one was methoxypropyl. So there is a change in parental chain, right? So that is the difference between metamers and position isomers. So please remember, with regard to your this one, when it comes to metamers, we will only go with ethers. Otherwise, we have many other examples, but we'll go only with ethers. Okay, for metamers. Any doubts in this classification of isomers? Any doubt? So they have asked many times from this particular part. So any doubt with regard to this one? And anyway, stereoisomers, no need to worry. It's not there for your first view. But when it comes to stereoisomers, it is based on the three-dimensional arrangement. How these elements are arranged in the space around the carbon. So that's where it is stereoisomers, where we have geometrical and optical isomers. Fine. Now we will come to next one. Some of the cleavages of the bond. That is related to cleavage of a bond in an organic compound. Okay. How a bond can be cleaved, or it will be cleaved in an organic compound. Now, for example, I have a molecule CH3. I will tell methyl chloride. This molecule is nothing but methyl chloride. Now you might be telling, sir, chlorine we should use as a prefix, but you are using as a suffix. This is a general name. We can call it as chloromethane, no doubt. We can call it as chloromethane. Okay, na? Because we know that halogens, they will be used as a prefix, not as a suffix. So methyl chloride is a general name. Chloromethane, we can call it as chloromethane. Okay. Now, there will be a reaction. There will be a reaction. For example, we have OH minus. We have OH minus. There will be a reaction which is called as OH minus. Now, this will be considered as a nucleophile. This will be considered as a nucleophile. Got my point? So now, 1 mark question or 2 marks question can be asked. What are nucleophiles? Give an example. Now I will tell. Nucleophiles are those species. These are the species having. Species, I'm not talking about biology, not that species. Okay, now it is related to chemistry. These are the species having extra electron, or these are the species, which will donate the electron, anything is fine. Okay, or we can tell these are the species which has lone pair of electrons, okay na? So anything is fine. So what I mean to tell here is nucleophiles are electron rich species. That electron can be of extra electron, where they will gain the negative charge. Listen to me carefully. Where they will gain the negative charge. So that's what? Extra electron. Only when extra electron is there, then only an element or a molecule can have the negative charge. Or in another way, we can tell that they are the one which can donate the electron. Okay? Or we can tell that which has the lone pair of electron. If lone pair of electron is there, that doesn't mean that it should carry the negative charge. Say for example, I have ammonia. Ammonia does not have any charge. Ammonia don't have any negative charge. But ammonia will be considered as a nucleophile. So what is the reason? Because there is a presence of lone pair of electrons. There will be presence of lone pair of electrons. That's where we have the nucleophiles. So which can be having a lone pair of electron, or which can be having extra electron, leftover electron. So therefore, nucleophiles will be symbolically mentioned with like this. Okay, that's where we have the nucleophiles. Then why this word, sir, nucleophiles? If you recollect, what is the charge of the nucleus in an atom? Can anyone? Whether nucleus is having any charge? Whether nucleus they are having any charge? If it is there, which is that charge present in the nucleus of an atom? Can any one of you tell me? What is the charge of the nucleus? Ashish is telling nucleus does not have any charge. All of us will agree with that? No charge. Even Rohan is telling nucleus does not have any charge. Okay, all of you are telling. But I disagree. Now Ashish is telling. Oh, now Ashish is telling. He changed the party. He cheated all of you. So no, Ashish is telling, or he is right now, nucleus will have positive charge. Yes, Shashank, very good. If you recollect structure of atom, that's where we have the nucleus, where we have a positively charged protons. Neutrons does not have any charge, that I agree. But protons, they have the positive charge. And that's where we have the electrons, which will be revolving around the nucleus. Okay, na? Rohan, is it positive? No question mark. It is positive. Okay, na? So nucleus will have the positive charge. The whole atom is neutral. That I agree. If I consider the whole atom, then it will be neutral because equal amount of electrons will be there. But when I focus only on the nucleus, it will have the positive charge. Right? So naturally, nucleophiles is they are electron-rich species. Normally, they will have negative charge, or they will be having lone pair of electrons. So therefore, they can attack the nucleus. They can attack the nucleus because nucleus is positive charge. So due to that, with that particular notation, they are given the name it as nucleophiles. Nucleus attracting, nucleophiles, nucleus attracting species. Okay, that's where we have the nucleophile as the name. Any doubt in this? Now on the board, I have given two examples. It can be OH minus, it can be ammonia, Even water, where lone pairs of electrons will be there, even that can be a nucleophile. All of you got my point? That's where we have the nucleophiles. Now, when these type of nucleophiles will be present, now that one will be considered as a attacking reagent. That one will be considered as a attacking reagent. Nucleophiles will be considered as a attacking reagent, which is attacking chloromethane. Okay. Now, during that time, since electron-rich species, I will go with OH minus. Since electron-rich species is approaching, now due to that, this particular carbon, yes, Rakesh, nucleophiles are those species which are having lone pair of electron or which will be having or which are electron-rich species. They can be negatively charged or they can be having no charge. But they will be having lone pair of electrons or extra electrons. Okay, so that's what I have written. Ammonia does not have any charge, but they are nucleophiles because they are having lone pair of electron. And ammonia is, all of us we know, it is a Lewis base which can donate the electrons, right? And at the same time, hydroxyl ion, OH minus. So that is nothing but hydroxyl ion. So hydroxyl ion is also a very good example for nucleophiles because electron rich species, negative charge is there. Okay. So why they are called as nucleophiles? Because since they are electron rich or having lone pair of electron, they can attack the nucleus. They will have affinity towards the nucleus. That's what, with that particular notion, they have given the name as nucleophiles. Nucleus attracting species. All of you got my point. That's where nucleophiles. So don't tell electron nucleus attracting species. Simply you can tell that nucleophiles are those compound or organic species, or these are the species which are having lone electron, lone pair of electrons or extra electron. Or simply we can call it as they are sorry, Appa, there was some this one. Okay, they are electron rich species. That's what you can tell. That's it. Okay. So now what I mean to tell you is, when I am talking about organic chemistry, so when I am dealing with the organic chemistry, we have only two types of reagents which will be involved in a reaction. At your this one, we have only two types of reagent. One is nucleophile and another one will be electrophiles. Now I am talking about a condition where we have an organic compound. We have an organic compound which is now going to react with the nucleophile. Which is going to react with the nucleophile. And that nucleophile I will consider it as hydroxyl ion. Okay. So when electron rich species will approach the carbon. Now carbon is under confusion. Oh, I am already satisfied. But still this OH minus is coming and considering, they are asking my help. Now what it will do is, it will talk to its chlorine that since you are electronegative species, you take these two electron with you. Anyway, I have a partner who is ready to donate the electron. Whether I am clear? Try to understand. So when OH minus, in this case I have taken nucleophile as OH minus. When a nucleophile like OH minus will approach methyl chloride, now the discussion will happen between carbon and chlorine. Now carbon will tell to chlorine that since you are electronegative, already these electrons are near with you. So take these two electrons, even my electron, you take it with you. Because I have a new partner who is ready to donate the electron, who is ready to invest the electron. Okay. Now due to that, what will happen here is CH3, Cl. Now there is a breakage of the bond. Now there will be breakage of the bond. What this arrow talks about, this arrow tells that both these electron is taken by the chlorine. So in turn, chlorine will become chloride because it has taken one extra electron which belongs to the carbon actually. So therefore it will become chloride. Now what will happen to this carbon? So it will gain the positive charge. It will gain the positive charge. Got my point? So whenever carbon is having positive charge, we will call it as carbocations. We will call it as carbocations. All of you got my point? That's where we have the carbocations. Very, very unstable in this case. I will come to that point. But whatever carbocation I have written, it is very, very unstable. That's where we have the carbocations. What do you mean by carbocations? So these are the carbon which is having positive charge. Now, can any one of you tell me? Can any one of you tell me what will be the hybridization present in carbocation? What can be the hybridization with respect to carbocation? Yes, Gauri, I will tell. Now, what will happen here is we have a nucleophile. So, try to understand this concept properly. Then you can easily write the organic chemistry reactions. Okay, Ashish, I will come to that. So that's where we have the hydroxyl ion, which is a nucleophile. Now they are approaching to methyl chloride. And when they approach to methyl chloride, where hydroxyl ion it will tell to carbon that I will invest the electron, you leave chlorine. You leave chlorine. Now therefore this carbon is like I'm taking simply one example, it's like a boy. Already one girlfriend is there, that is chlorine is there, but still a new girlfriend, new girl came and approached. It will leave this particular old girlfriend. This is an example, okay? So that's where this carbon, now it will want to leave this chlorine and it will make a new linkage with the OH minus. So for that, what will happen? So before going for that, this bond has to be cleaved. Okay, this bond has to be cleaved. Yes, Rohan. It should be sp2. I will come to that. So this bond has to be cleaved. So where both the electrons it will be taken by the chlorine, so which will be released as chloride, negative charge. Why one negative charge? Because along with its chlorine, it is also taking one electron from the carbon. Along with its one electron, this chlorine is taking carbon electron also. So therefore it will become chloride. Another example for nucleophile. Cl minus can be an example for nucleophile. Okay. Now electron rich species. Okay. So now this carbon, since it has lost one electron, naturally it should gain the positive charge. And we will call it as carbocation. We will call it as carbonium ion or carbocation. All of you got my point? Now this carbocation is unstable. So immediately it's going to react with the OH minus to form a new molecule which is called as methanol. Which is called as methanol. Which is one of the reaction which you are going to study in your second period. Okay, Gauri. Okay, done. So that's where we have the reaction. That means methyl chloride in the presence of OH minus will get converted into methanol. What will be the another product? Another product will be chloride. Now, if you observe, in this reaction, one nucleophile is going out and one nucleophile is coming inside. Got my point? So one nucleophile is going out and one nucleophile is coming inside. So therefore, this can be an example for nucleophilic substitution reaction. This can be an example for nucleophilic substitution reaction. All of you got my point? So nucleophilic substitution reaction. Why? One nucleophile is substituting the another nucleophile. It's very simple. Now, if you take day before yesterday, your chemistry class was taken by Rachita madam, right? That means Raghavendra sir is substituted by Rachita madam. So one chemistry faculty is substituted by another chemistry faculty. That's where substitution. Got my point? Same logic is applicable here. So one nucleophile, that is chloride, is substituted by another nucleophile, that is OH minus. So that's why we have the nucleophilic substitution reaction. Okay. Now if you observe here, I have taken the example of nucleophile as chloride, OH minus, ammonia. All of them, they can be an example for nucleophiles. But on the board, we have another species which is electrophile. Can you tell me which is that one? On the board, we have another species which is called as electrophiles. Can you tell me which is that one? On the board itself, it is there. On the board, it is itself, it is there. Which is that one? Ashish, I'll come to that. It is sp2. I'll come to that. But before that, you should tell me. Which is that electrophile which I am talking about? No, Shashank. So I will write here on the board whatever nucleophiles are there. I am writing it on the board. Okay, that is ammonia. Since it is having lone pair of electron, then OH minus, then Cl minus. They are all examples for nucleophiles which is there on the board. So ammonia is a nucleophile because it is having lone pair of electron. OH minus because it is an electron rich species, negative charge. So chloride because electron rich species. Please listen to me. I am not telling chlorine. I am telling chloride. There is a difference between chlorine, chloride. So I am talking about chloride, which is an example for nucleophiles. Now can you tell me which can be the example for electrophiles then? Anyone? Okay, it can be carbocation. This can be the example for electrophiles. Carbocation because electron deficient species. Yes, Gauri. So that's where I have the another category. I will remove this one. I have another reagent. I have another reagent that it is called as electrophiles. Where it is called as electrophiles. Whatever is there on the board, carbocation, it can be an example for electrophiles. Haga, what do you mean by electrophiles? The symbol itself for electrophile is E plus. So what do you mean by electrophiles? Electrophiles are those species which are electron deficient in nature, or electrophiles are electron deficient species. Exactly opposite to that of the nucleophiles. Electrophiles are electron deficient species. All of you have understood? So that's where we have the electrophiles. So why they are called as electrophiles? Same logic. Since electrons are negatively charged, so electrophiles are those which have affinity towards the electron. Electrophiles are those which are having affinity towards the electron because electrophiles are electron deficient. So they want to have the electron. So therefore, they are having electron affinity. Nucleophiles are having nucleus affinity. Electrophiles are having electron affinity. So based on that, they have given the name nucleophiles, electrophiles. All of you got my point? Any doubt? Whatever I have written on the board? Any doubt? We have many other example for electrophiles. For example, we have nitronium ion, NO2 plus. We have the nitronium ion, NO2 plus, which can be an example for electrophiles. Then we have chloronium ion, Cl plus, which can be an example for electrophiles. Anyway, that one we will discuss it as and all it will come. But for time being, you can remember carbocations, nitronium ion, chloronium ion, Cl plus. They are all examples for electrophiles. Okay. So they are all examples for electrophiles. Electron deficient species. Electron deficient species. So that's where we have the electrophiles, nucleophiles. So these are the two types of reagents which will normally involved in with respect to reactions. Which will normally involved with respect to the reactions. ಹಾಗಾದ್ರೆ okay, fine. Any doubt up to here now? All of you got my point? What is the definition for electrophiles? They are electron deficient species and will have affinity towards the electrons. Okay? And nucleophiles are electron rich species. That's where we have two types of reagents. Okay? Done. Now that's what we are talking about. If you observe it carefully, 1 minute, if you observe it carefully, in this reaction there was formation of one cation and one anion. All of you got my point? During this reaction there was formation of one anion and one cation. All of you have observed that one. There was a formation of carbocation and there was a formation of chloride. So CH3 plus Cl minus. So whenever this type of reaction happens, where towards one element electrons will be shifted, or both the electron of this covalent bond, when it is taken by the one element of that particular bond partners, then it is called as heterophilic, that is heterophilic cleavage. It is called as heterophilic cleavage. Okay, so that's where we have the one type of bond cleavage which is called as heterophilic. Hetero means not uniform. Why it is called as not uniform? Because only one element is gaining the electron and another element is not gaining any of the electron. Therefore, it is called as heterophilic cleavage. Okay, therefore it is called as heterophilic cleavage. So this heterophilic cleavage can happen in the presence of electrophiles or in the presence of nucleophiles. In any of the cases, heterolytic cleavage can happen. Just now we have discussed, I have a compound Rx and I have a nucleophile which has approached. Now during that time, there will be heterolytic cleavage. So RNU plus X minus. Okay, same way. If I have Ry which is approached by a electrophile. Now opposite bond will be cleaved like this. Now what will happen? R electrophile with Y positive. Got my point? Nucleophilic, electrophilic substitution. So nucleophilic substitution, first one. Electrophilic substitution, second. So that's where we have the two major types of reactions in the organic chemistry. So nucleophilic substitution reaction and electrophilic substitution reaction. So in both the cases, what is happening? There is a heterophilic ion. There is a heterolytic cleavage. There will be heterolytic cleavage. Okay, so that's where we have the heterolytic cleavage. Any doubts in this? Any doubts? All of you have understood properly? Hmm? Done. So please remember about carbocations. Now I'll be talking, before going for another category, now I'll be talking about the stability of carbocations. Now I'll be talking about the stability of carbocations. And please, in second year on this concept, we have many other reactions. So try to understand it properly. Now I will write one of the carbocation, that is CH3 plus. Now I will be talking about carbocations. Okay. So I have one of the carbocation, that is methyl carbocation. Okay. Then I will write another one, right? Ethyl carbocation. Then I will write CH3. Okay. So propyl carbocation. And this is isobutyl carbocation. Now if you observe it carefully, what is that difference between these carbocations? Whether all of them they are same, where carbon is having positive charge? Yes. In all the cases, carbons are having positive charge, no doubt. But if you observe it carefully, the environment around those carbons are different. Environment around those carbons are different. In this case, carbon is bonded with 3 hydrogen. In this case, carbon is bonded with 2 hydrogen and 1 carbon, because if I want to write the detailed structure, then I can write like this: hydrogen, hydrogen, positive. That means carbon is bonded with 1 carbon and 2 hydrogen, right? But in this case, all are hydrogen only. No carbons are there. Fine. Now if I come to this one, CH3, right? CH, positive charge, and CH, H, H. Only one hydrogen is attached to carbocation. But if I come to here, so where carbon is attached with only carbon, no hydrogens. Carbon is attached with only carbon. Which carbon I am telling? Carbocations. All of you are understanding? All of you can see the board? So that's where I have the differences between that. That's where I have the differences between them. In first case, carbon is attached with 3 hydrogen. In second case, carbon is attached with 2 hydrogen and 1 carbon. In third case, carbon is attached with 1 hydrogen and 2 carbon. And in the last case, carbon is attached with 3 carbons only, no hydrogen. Any doubts with respect to all this explanation until now? Fine. So shall I move to the next step now? Okay. So now this one is called as methyl carbocation. This one is called as methyl carbocation. Now this one is called as primary carbocations. Instead of calling it as ethyl, we can call it as primary carbocation. Okay, and this one will be called as secondary carbocations. Secondary carbocations, and the last one will be called as tertiary carbocations. Last one is called as tertiary carbocations. So this one term, this one we can call it as primary. This symbol is acceptable. So primary, secondary, and the last one is tertiary. And the last one is tertiary. So that's where I have the difference. Okay, that's where I have the difference among these species. Any doubt until now? Hmm? 1 minute. That's where I have the difference among these species. If you have any doubt, you can ask. So how many types of carbocation I have written? Methyl carbocation, primary carbocation, secondary carbocation, and tertiary carbocation. How they differ from each other with respect to number of hydrogens or with respect to number of carbon around them. Okay, yes, go 4 types. So how they differs these carbocations? That depends on number of hydrogen and the number of carbon with which they are making bonding. Okay, so that's why we have the different types of carbocations. Now listen to me carefully. For your competitive exams, it will help you out. So when I am talking about methyl carbocation, it is unstable compared to primary carbocation, which will be unstable compared to secondary carbocation, and which is unstable compared to tertiary carbocation. So whatever I have written, it is the increasing order. It is the increasing order of stability. It is the increasing order of stability of these carbocations. There is an increasing order where methyl carbocation, they are very unstable, and whatever is there on the right side, tertiary carbocations, they are very stable. So that means we cannot compare methyl carbocation with the tertiary carbocation. Methyl carbocation is far less stable compared to tertiary carbocations. Or I can tell that tertiary carbocations are very stable compared to methyl carbocations. So they are not at all comparable with respect to their stability. So try to understand this, because if you understand this one, you are going to understand many of the reactions even for your second P. Many of the reactions with respect to your second P, you can understand easily. Okay. So any doubt? Now, someone had asked, how come it will be Sp2? If you observe all these carbocations, I am not talking about these carbons. I am talking only about the carbocations. If you observe them, all of them, they are having only 3 linkages. All of them, they are having only 3 linkages. That means 1, 2, 3, 4, 5, 6. So if I go with Lewis dot structure, how many electrons they are having? Only 6 electrons. That means they are sextet in nature. They are not octet, they are sextet. That means 6 electrons. They are sextet in nature. They don't have the octet nature. So therefore they are unstable. This is one of the reason why carbocations are unstable, because they are not in octet state, unlike other carbons. So this carbon, octet state, 1, 2, 3, 4, 5, 6, 7, 8. So this carbon stable 1, 2, 3, 4, 5, 6, 7, 8. Because all of them, they are in the octet state. But in carbocation they are sextet in nature. That means 6 electrons after the bond formation. And how many sigma bonds are there? 3 sigma bonds. So naturally it should be sp2 hybridization. It should be sp2 hybridization. because number of sigma bond. Double bond, it can be, but anyway, it's not present here. Even if they make the double bond, then it will be only 2 sigma bonds will be there. Then only 2 sigma bonds will be there. Okay. So whether you got the point? But only thing here is if they can't make the double bond so easily, or they cannot make because their electron is empty, their p subshell is empty, they are having positive charge. They are having positive charge. So they cannot make the double bond easily because their p subshell is empty. Got my point? Any doubts? So these are some of the points related to carbocations. So these are some of the points related to carbocations. Why carbocations are unstable? Because carbons are in that sextet test, or you can simply write it as they are not in octet state. So therefore carbocations are unstable. However, among the carbocations which is quite stable, the quite stable carbocation will be tertiary carbocations. It can be tertiary carbocation which will be stable. Okay. So when it comes to methyl carbocation, only one example. But all the other carbocations, many molecules can form those type of carbocations. But methyl carbocation, only one, that is methane. But for all the other, we have plenty of examples. For example, I have taken for primary ethyl group as the example, but it can be with propyl group also, right? So with respect to secondary, I have taken the example of propane derivative, propyl group. It can be with butyl also. So what I mean to tell here is, except methyl carbocation, for all the other carbocation, there can be many examples. Okay. Now, the answer for why tertiary carbocations are stable. Okay. So that is the question. Why tertiary carbocations are stable? Now to answer this one word answer is that is due to hyperconjugation phenomena. That is due to hyperconjugation phenomena or due to hyperconjugation. Okay. So what is this hyperconjugation? So we are not understanding, sir. See, for example, I have a tertiary carbocation, okay, which I had written earlier. Same thing I will write H, H, H. Okay. Since this carbon is having positive charge, it will approach any of these neighboring carbon. It will approach any of these neighboring carbon and it will beg them. So please help me out. I'm not in octet state, I'm in sextet state. I want to have the stability like you people. So please help me out. So due to that, what will happen? Any of these carbon, for example, if you take this carbon, so what it will do is, it will take the electron from the hydrogen and that's where it will make a double bond. This will make a double bond with the carbocations. It will make a double bond with the carbocations. That is possible, but this is not like this only permanently. This hydrogen will come back. Now this hydrogen or this hydrogen or this carbon, this hydrogen or this like that, this double bond will be shifted throughout the options. Throughout this carbon, double bond will be shifted. That's how the carbocations will be stabilized. That's how the carbocations will be stabilized. That's why it is called as hyperconjugation. That's why it is called as hyperconjugation, because there is a shifting of the double bond. Okay, all of you have understood? and hyperconjugation is a permanent effect. Until unless this tertiary carbocation is there, hyperconjugation will be there. So therefore, it will be a permanent effect. It will be a permanent effect. Okay. Now, if you take tertiary carbocations, they have many of the options to go for hyperconjugation. They have the many options to go for hyperconjugation. But when you go to the secondary, one option will get reduced. Because in this case, only two carbons they can do this particular function. Only two carbon they will do this particular function because another one is hydrogen. Option got reduced. If I come to primary, so much more option will be reduced because it is attached with the two hydrogens. It is attached with the two hydrogen, only one option. But when it comes to methyl, no options at all because all are hydrogens. All are hydrogens. Got my point? So this is the reason due to the hyperconjugation, tertiary carbocations are stable. In general, yes, carbocations are unstable, no doubt. But when it comes to tertiary carbocation, they are quite stable because of the hyperconjugation phenomena. Due to the hyperconjugation phenomena. All of you have understood? Any doubts? Fine. And due to sp2 hybridization, tertiary carbocations can make trigonal planar structure. Due to the sp2 hybridization, tertiary carbocations make trigonal planar structure. Otherwise, carbon will make tetrahedral structure. Please remember, they will make tetrahedral structure. But in carbocation form, they will form planar, tertiary planar structure due to sp2 hybridization. Any doubt in this? It's a 1 mark question if they ask. Give reason for the stability of the tertiary carbocations. You can just tell that due to the presence of hyperconjugation. 1 mark will be given to you. Or if they ask, what is the reason why methyl carbocations are highly unstable? Then you can tell that due to the lack of hyperconjugation. Due to the lack of hyperconjugation, you will get the 1 marks. Any doubt in this? So, sir, they form double bond? Oh, that one. All of you got the point? Okay, so what we have discussed today? First, we discussed about difference between chain isomers and metamers. Chain isomerism, positional isomerism and metamerism. That's what first we have discussed, right? Position, isomerism and metamerism. What is that difference? Okay. Then we have discussed about nucleophiles, which are electron species, and electrophiles, which are electron deficient species. Symbolically, we can mention it as E positive and this one as Nu 2 dots, which indicates the lone pair of electrons. Okay. Then we have discussed about heterolytic cleavage. What do you mean by heterolytic cleavage? And under which condition heterolytic cleavage will happen? Then we have discussed about carbocations. Then we have discussed about the carbocations. So in this one they will ask, this one they have asked, this one also they will ask. Especially first two they have asked. Got my point? Any doubts with regard to today's class? Anyway, I will stop here. Any doubts? So these are the things which we have discussed. So you can read, you can go through the textbook and check sheets And if you have any doubts, Monday you can ask me. Okay? And with regard to the carbocation, they are very important for your competitive exam also and for your board exam also, especially for second PU and all, it will help you out. Okay, na? Okay, then if you don't have any doubts, I will stop here and we will meet on Monday. Until that time, so please go through IUPAC nomenclature, practice it, go through the check sheet and textbook. Fine. So thank you. Thank you very much. Take care.